We'll continue with the calculation of curve length. Now rather curve length, it would be curvature length. I mean the surface area of curved surface. So that is the concept. So this is where we will make the progress from 2D to 3D. So that is the idea. Okay, so we have kind of what we have done. So if I see, then what we will do? So we will calculate the surface area of a surface area of a kind of sphere, surface area of a sphere. But what we have done, whatever we have done by now, is that we have calculated the circumference of a circle. So if I have a circle, if I have a circle, I have a circle. If I have a circle and circle has a center and then circle has a radius. Radius rotates around a center. Okay, so radius rotates around center like this. So this is the circle centered at origin. This is origin 0 comma 0. This is a xy plane on which the circle is standing. Circle is placed. Now, what is the perimeter of this circle? Length of the perimeter, length of a curve. So that is in question. So what is the kind of what is the length of the what is the length of the curve? That is the question. Now, if I want to now calculus, calculus is game of algebra. So we know very well that calculus is game of algebra. If person is in depth in algebra, then calculus is a tool for manipulating the algebra. I always kind of say that calculus is not game of infinitesimal small distance. This is what every book, whatever book you take, if you want to integrate something, then we take infinite region somewhere, and then that region will take the vertical, then that I'll calculate the area, then we will make it span over all the area, then we'll integrate. If you do like this, certainly you cannot do machine learning and artificial intelligence. Okay, so if you kind of you are a slave, or if you have do not, if you are on a kind of some tool, and then you are walking like this, then you cannot run marathon race. Okay, so or if you can win 100-meter race, it is not required that you can win 40-kilometer marathon race. So if you want 40-kilometer marathon race, then you have to understand things in depth. So this I've seen many proof. I'll take one strip here, and a strip is this, and now the height is so small that even though it is not vertical, but we consider it vertical, and then we'll manipulate. Now mathematics is not approximation. Mathematics is not mathematics not imagination. Mathematics is the most perfect and most concrete thing among all the sciences. There is no approximation, and consider like this, and this distance, that distance, and then if this is a slant, still I consider it is a height, and then I multiply like this, and then I'll take over all the surface and I calculate the surface. There are all mathematics book, they would start with infinitic, small strip, and this and that. Mathematics has, you can take it. I'm not saying you don't do like that, but it is called approximation. And there are other terms also through that you can, this is called also called kind of numerical integration, where you divide into so many parts and each part you calculate the area, approximation, and you go and add. These are the way places where we cannot calculate the integration. Integration algebraic equation comes in a form that we cannot do the integration. This is our fault. For each possible function, each possible algebraic function, there should be integration. Integration starts from rectangle. Integration is calculation of area. That's it. So integration starts from rectangle. Then triangle. Triangle is half of the rectangle. We can find it. From the triangle, we have a slant. So slant equation is x, then x square. So polynomial, we can, well, this way, layer by layer, we start finding the area. So integration is nothing but calculating addition through the area. If you know the area of some algebraic equation, you have done with the integration. There is nothing more. There is nothing more towards it. So that is kind of calculus or integration. Or if you have the if you know the area, if you know the net, if you know the net addition, and from net addition, if you want to find the kind of rate of change, then you differentiate it. That's it. Okay, that's why Python language become very famous nowadays. Don't complicate. Big things are always very simple, like human body. Tell me one person in the world, one doctor in the world, so many doctors are there. Tell me one doctor in the world who understand even 0.0000000 to infinite 1% of the body. Okay, but if body is so complex that not even a single person understands, I am saying like this because anyone can catch disease and he can die. So no one understands the human body. A big to biggest doctor also is prone to corona, is prone to cancer. So he may also die with the disease. Okay, so no one knows anything about the body. If you tend to die, if you're not tend to catch some sneezing problem or something, if you tend to die with this kind of disease, any doctor, this proves that you don't know anything. You know little bit of the body, then certainly you can avoid death also. But this is what Krishna says in Gita. If you know little bit of also of the body, then you can avoid big disaster. Means that much. But if you, I cannot go beyond it. Okay, so I'll leave it here only. Anyway, so calculus is a very big thing. Calculus is a very big thing. But if you kind of big things are always very simple. Very complex things are very simple. That's why it is complex. The person who designed, okay, he will never design complex thing through complex way. Complex thing from user perspective, the machine is very complex. If it touches, usability may be easy. What is usability of a human? Only eye, nose, mouth. That's it. But if you go inside, no one can understand. But the external feature that is given to human, he interact or he see other interacting him, mainly mouth only. So that much. Okay, but inside it, it is very complex. Like that, if someone is designing a machine, inside of the machine is very complex. For user, it may be simple. But for the developer also, it is very simple. Okay, if developer design any complex system through complex way, then today he may design, tomorrow he will not able to understand it also. A developer tomorrow when he sees how through very highly complex way, if he had designed a complex system, tomorrow it will be out of his brain also. So a developer who has designed a very complex system, more complex is the system, the more simpler design. This is how he does. So that tomorrow when he goes up to the machine, then quickly he can modify it or whatever. Okay, so complex thing behind the complex x, behind the complex it is x, s, s, simplest. So simplest design, simplest thinking can only bring the complex system. So if calculus is complex, then it is brought through very simple method. So complex starts from integration, and integration is nothing but a way to do the addition. That's it. How calculate the area? Simply calculate the area of a algebraic equation from a limit left to right, you get the integration. You do the reverse of integration, that is differentiability. So if you have area, you want to get back your algebraic equation, you differentiate. So it starts from addition through calculation of the area. That is integration. Take infinitesimal distance here and take a strip here and take one small part of it, and then this dx dy, and then suppose it is delta x and d complex way can never create a complex system. Not possible. So simple way only. So what is the meat? And this is what I have talked. What is the flesh inside the calculus? That is the algebraic equation. You have to be very powerful in deducing the algebraic equation. Then calculus is yours. Consider that I have a line. If this is x-axis, if this is x-axis, this is x-axis, and this is y-axis, from the origin I have a line. The equation of line is x, fx equal to x, y equal to x. Okay, if on the x-axis there is a point called alpha, then vertical also it is alpha, x. Okay, so if x is x, then y is also x. So this is a triangle. Now, what is the integration? Now we know that area of the triangle is area of the rectangle divided by 2. So area of the triangle, it is x and x square by 2. Now we know that if equation is x to the power 1, then integration is x square by 2. Suppose there is a flat line. This is x to the power 0. If it is x to the power 0, integration is x. Okay, so people consider that if it is x to the power n, then it is x to the power n plus 1 divided by n plus 1, whatever. Now the integration of this x is x square by 2. What is said? This this line is rate of change. This is what we talk. Like person has started walking from the rest. No speed. Now he is walking and he is increasing his velocity. Now he is ramping up in his velocity and he is walking. So at any moment, what is the speed? That speed is x. Speed is growing. This is the speed graph. If speed is growing, at this point, how much distance he has traveled? That is the question. So here, if x is 1.5, then he is at a speed 1.5 kilometer per hour, like that. So at the end of 3 hour, when x is 3, at the end of 3 hour, how much distance he has traveled? Now I'll take one dx, small length, and then this is so small that this height you can consider as flat only. Then rectangle. You have to make a then expand. These are the philosophy, not work right. That era is over. If you want, so what you are doing is collection of, this is the collection per hour is the speed. Speed is nothing but how many kilometers a person is collecting per hour. Collection of kilometers per hour. That is not known. At every point, the collection per hour speed is would vary. But if I calculate the area, if it is collection per hour, and if I calculate the area means whatever is the this multiplied by this, collection per hour into hour will be net collection. So idea is if I calculate the area of this, then I get the net collection like this. If this is a horizontal line and collection per hour here is a constant. Suppose 3 kilometer per hour he is collecting. It is a constant. This is x-axis hour. How much he has collected at the end of 3 hours. Then that is the area of this rectangle. So 3 into 3, 9 kilometer he has collected. So if I calculate the area, I get the net collection. So if this is the, then what is the area? So if this is the true, then if this is x, this is x, then this is x. So rectangle is x square, x square. So this is half of the rectangle, x square by 2. So at the end of 3 hours, 9 by 2, 4.5 kilometer he has traveled. This is integration, not delta x infinitesimal small. Means integration is something that will come with a big power. It will not come as infinite way. Now, what is infinite? It is infinite. If I want x between this 0 to 3, how many x I can calculate? Infinite. Any x you can take. Since it is algebra, it would vary for each x. That is the concept. Now, area is again a function over x square by 2. What is, how much he has traveled when x equal to 1? Then half kilometer. If hour is 1, then at this point, when at the end of 1 hour, how many kilometers he has traveled? 1 square by 2, half kilometer. So x square by 2, again it's an algebraic equation. And then that is the net collection. Net collection is, is a function over x. Keep changing x, you get the net collection. So if x equal to 5, at the end of 5 hours, how much he has traveled? 25 by 2. That is the concept. Now, how much he has traveled between second hour to third hour? In 1 hour, that is from second hour to third hour, how much he has traveled? If that is the case, then from origin to third hour, how much he has traveled? Calculate that from origin to second hour, how much he has traveled. Because whatever you are placing x value in x square by 2, whatever x value you are placing, that x value is from the origin, that much area it will take. So from the origin, 3 you replace, then 9 by 2, then 2 you replace, then 4 by 2, 9 by 2 minus 4 by 2, that much distance he had traveled from second hour to 3 hour. That is limit. If I do integration, so if I do fx dx, fx is x, fx dx x. Dx is just notation that fx is a, fx I have to calculate along the x-axis, fx along x-axis. If it is not satisfiable, then place dx, otherwise dx is also not required. Fx integrate 2 to 3, okay, from 2 to 3. So 3 rectangle first, 3 triangle first minus 2 triangle second. So this is how the integration works. Simple. That much only. It's not infinitesimal distance. If you land up in those kind of region where I take infinitesimal distance here and consider this is so small that it would look like a straight line even though it is a curve. And if it is curve, then this is not the way we deal. That's why we are here. Otherwise, you can read the book also. Anyway, now idea is how I can find the circumference of this circle. This is what we are doing since the beginning. Now, if this is a circle, and if this is the circle, then what is the constant algebra? Algebra changes as we change the x. Now, if this is x-axis and this is y-axis, then x is independent component. Y is dependent component. Y equal to fx, function over x. Now, if I see the relationship between fx and x or y and x, if circle is centered on the origin, then it is x square plus y square equal to radius square, r square. Consider r as 1. Then x square, then y equal to 1 minus x square. Now, if this is origin, this is x-axis, this is y-axis, then at any point on the circle, if I, from the center, if I draw a line, this is the vector. This is called position vector. Everywhere position vector would be different if it is in function of x. This is calculus. You have to be very serious about function over x. What is that algebraic function? Algebraic. Calculus is game of algebra. Calculus is not game of infinitesimal small distance here and there. It's a game of algebra. So you have to find at the end the algebraic equation. That is the meat. That is the fruit bait. flex, that is the flesh, nowadays fruit flesh. Okay, so that is the meat. So what is the kind of, so what is the position vector here? Position vector I have to find in algebra. If it is a vector, it has x component and y component. If this is x-axis, then certainly there will be x component and y component. X component is x, then y component is fx, function over x. That is 1 minus x square root. If that is the case, if this is position vector, then what would be dp by dx? If I made small change at any point x, okay, at any point x on the x-axis, what is rate of change that is seen in position vector? Means if I make 1 unit of change, now position vector would vary. Can you see this? Position vector is varying. If it is varying, because everything, if variation happens, it will be guided by independent component, x-axis. So if I keep changing x-axis, then position vector would vary. If x is 0, then position vector is like this. If x is 1, then position vector is like this, because radius is 1. If x is changing 1 unit of distance, then how many unit p would change? dp by dx. dp by dx is rate of change, where per unit change in x-axis would bring how many unit of change in p vector, not on y-axis, on p vector. dp by dx, that would come as I, because xi means I, differentiation is I. Square root of 1 minus x square means minus x by square root of 1 minus x square j. This is called dp by dx. It is also called velocity vector. If we see dp by dx, that is I minus x by square root of 1 minus x square j, when x equal to 1, then it is I minus infinite j. Means the vector, when x equal to 1 here, x component is 1, but y component is infinite. Means there is, if I have a vector where x component is 1 and y component is infinite, it is considered as a vertical vector. So minus means it is going down. So minus infinite means it is like this. So, but if x equal to 1, then it will be I. Y component is 0. If vector is I, means it is like this. So, this, the dp by dx, that is a vector, that is a tangential at any point p. It is keep on moving like this. So, when x equal to 1, it is vertical. When x equal to 0, it is completely horizontal. So, this is velocity vector. Velocity vector is also in form of algebra. If it is in form of algebra, then it is a function over x, and as x is changing minutely between 0 to 1, how many x value can happen? Infinite. Okay, x can be 0.0000540033, means infinite. Between any 2 point, x can be infinite. So infinitesimal small is anyway included in the algebra. So if I have a position vector that is moving like this, then velocity vector, differentiation of it, is actually tangential to the position vector, and it is moving like this. If this is the velocity vector, then at any moment, what is the length of the vector? If it is velocity vector, then velocity vector starts from x equal to 0, then keep on moving like this. What is the length of velocity vector? Okay, if velocity vector, vector v, is, now velocity vector is I minus x by square root of 1 minus x square j. What is, any vector has direction and magnitude. I showed the direction, but I did not tell you the magnitude. Magnitude is now 1 square plus x square by 1 minus square root of 1 minus 1 plus x square by 1 minus x square whole square. That will come as 1 minus 1 by 1 minus x square complete square root, or 1 by square root of 1 minus x square. That is the magnitude of the velocity vector. Now I have is a kind of, if I have dp by dx is velocity vector, then d length, magnitude means dl by dx we have calculated. If I know dl by dx, then if I integrate, then rate of change, if I know, if I integrate, I get the net quantity, that is the length. These are fundamental. What is the length? So length is like I told you that if person is walking 3 kilometers per, if a person is walking at a speed that is x, that is the triangular slope x. At any moment, what is its speed, that is x. How much distance he has collected at any moment, that is x square by 2 from the origin. Okay, so if I have a velocity vector starts when x equal to 0, then how much distance it has collected, that is the integration of dl by dx. dp by dx, p I converted to L, calculating the length, dl by dx if I integrate, then that one. But length is again, it is a function over x. So length is changing as per the algebraic equation. What is the net length from the origin? Calculate the integration, probably you will get back net length as function of L1, x1. That is a class of algebra. So if L equal to 1 by a square root of 1 minus x square, then from origin, if you integrate it, then you will get the if 1 by 1 minus x square is L, L is again a algebraic equation where you have x axis and y axis fx, then there is some function. If you calculate the area, you get the net length. This is what is required. So 1 by 1 minus x square dx and integration. Now, if you don't use integration, then it will be in function of x only. Keep replacing x and you get from here the net length from the origin. Now, what is the integration of 1 by 1 minus x square? If we know, if we want that, then we have to use trigonometry, and if x equal to, or if someone is very powerful in algebra, then directly he can calculate it. So 1 minus x square. So if I consider x as cos theta, if x as cos theta, then if I place x square plus y square equal to radius square, that is the equation of circle, then y would be certainly sine theta, cos square theta plus sine square theta. Or someone can take r cos theta, then r square cos square theta plus r square sine square theta equal to r square. It will come. So fx would be, if x is r cos theta, then fx would be r sine theta, that is y. Anyway, now r is 1, so I consider x equal to cos theta. So 1 by a square root of 1 minus cos square theta would be 1 by sine theta. Now cos theta, if x equal to cos theta, then dx equal to minus sine theta. So minus sine theta d theta divided by sine theta. So minus d theta. So minus theta is the integration. Now I have to integrate from, now I want from here to here, half of the circle. From so minus 1 x is minus 1 to 1. Okay. Now what is theta? If x is sine theta, when x is 1, then theta is pi by 2. When x is minus 1, then theta is minus pi by 2, if x equal to sine theta. Then theta minus 1 to theta, where x is minus 1 to 1, then theta is minus pi by 2 to pi. Then it will become pi. I'm sorry. Okay, so it is theta. So theta, I have to now integrate from minus 1 to 1. Okay, so there is some locha here. So cos theta d theta, I was cos theta d theta minus theta, I have to integrate, and this should land up in minus 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 d theta. So it land up in theta. Okay, if it land up in kind of theta, then what is the theta? So cos theta equal to x, not sin theta equal to x. This is what our assumption. So cos theta equal to x. If x is 1, then theta is 0. Radian 0, cos 0 is 1. When x is 1, theta is 0. When x is minus 1, then theta is 2 pi. So now it is 2 pi to 0. So now, okay, so 1 to minus 1. So 1 is 0 and minus 1 is 2 pi. So it will be now 0 minus 2 pi. So minus 2 pi. Outside minus, then pi. Cos pi is 180 degree. Pi is minus 1. So pi to 0. So it will become minus pi minus minus pi. So the length of this vector, this half is pi, then full length is 2 pi. Now you can begin all full calculation with the r cos theta, x equal to r cos theta, and then you can go with the full calculation again. Then you will end up in 2 pi r. Okay, now it is 2 pi, r is 1, it will land up in 2 pi r. Now this is the concept that we have used in a kind of, someone can go with the polar coordinate also. So that we will see. But today idea is that I have to calculate curvature. Curvature means surface of a sphere. I really have a sphere. So this is a sphere. If this is a sphere, then what is the surface area of a sphere? That is in question. Now, what we did last time, we actually deduced the surface area of a sphere. What is the idea behind calculus is, for everything you have to calculate. I mean, I'll go back to the last. I talked about length will be in variation of x. So at the end we got the theta and we calculated we can go other way also. If cos theta equal to x, then theta equal to cos inverse of x. So net integration is minus cos inverse of x, where limit is minus 1 to 1. So cos inverse of 1 is 0, cos inverse of minus 1 is pi, then minus pi minus. So what is the idea is, from beginning everything what we are getting, it is in function of x. So net length is also in function of x, cos inverse x. If I don't use limit, then whatever x I am substituting now from the origin, it would give the length. So from the origin, it would give the length. If I set x equal to 1, x equal to 1, then cos inverse 1 is 0. Cos inverse 1 is 0. So if x, okay, I'm sorry, if x, I am taking, someone can try, if x I am taking, if x I take as 0, if x I take at 0, then cos inverse of 0, cos in x, if x I take as 0, then cos inverse of 0 is cos inverse 0 is pi by 2. So the length is pi by 2. So somewhere it is taking from somewhere. I believe you can calculate. If I take 1, then 1, then it is 0. The length is 0. When cos is 1, the length is 0. Means it is calculating from here. So it is calculating from here. So if length is 1, I am taking length is 1, then cos inverse 1 is 0. Then the length is, so it is taking from here. If length is 0, then it is pi by 2. If length is minus 1, then it is pi. So it is calculating from here. Okay. So one point it will take, and from there it will start the calculation. Okay, if I take cos theta, x equal to cos theta I had taken. If I take x equal to sine theta, then it will be sine inverse x. It will take sine inverse x. Okay, I mean I can go more in it. It came as minus theta. the net integration came as minus theta minus cos inverse x. That is the result, minus cos inverse of x. If x is 0, okay, if x is 0, then it comes as pi by 2, minus pi by 2. So it would start minus pi by 2. If it is 0, then minus pi by 2 is here. I was talking it should start from here. It is starting from here. So we are right. Means it starts from x equal to 0. That was the concept, not x equal to 1. So it is perfect now. Now minus, if it x equal to 0, then it is pi by x equal to 0. X equal to 0, cos inverse 0 is 0, is cos inverse 0 is pi by 2. When x equal to 0, then what is the kind of length, that is minus pi by 2. It is coming like this. When x equal to 0, x equal to 1, then it will be, I mean, you can calculate. So this is the kind of the length we are getting as function of x. I believe I'll try with the sine theta. So if x equal to sine theta, then 1 by a square root of 1 minus x square will convert it to cos theta. Now, if x equal to sine theta, then it will come as cos, dx is cos theta. Cos theta will cross. It will come as d theta. Integration is theta. Now, theta means sine inverse x. Sine inverse x. Now, if this is the integration, when x is 0, then sine inverse x is 0. Okay, now it is perfect. When x is 0, the sine inverse x is 0. So now it starts from here. Okay, now if x is 1, then sine inverse x is 1 is pi by 2. So it has, from here it travels this much. So this distance is pi by 2. Okay, now if x is 1, then it is pi by 2. When x is 0, then it starts from here and it is 0, like this. When x is minus 1, then it is minus pi by 2. So from here it goes in negative direction. Perfect. It will be perfect with cos theta also. You can try. Okay. Now let's see if I want to measure the curvature. Curvature means surface of a sphere. Now idea is same. I have to concentrate on the algebraic equation. That is the idea. Now if I want to calculate on the algebraic equation, then what is the equation that we will now proceed? So we came like, what is the position vector of any point? If this is a sphere and the sphere is centered on the origin, so the center of this sphere is lying on the origin, then any point on the sphere, that is from center, any point P on the sphere is x comma y comma z. X axis, y axis and z axis. Any point on the surface of the sphere is x comma y comma z. That is x comma y comma fxy, function over x and y. If this is x axis, this is y axis, then this is xy plane. If this is the xy plane, then both independent components x and y, they lie on the xy plane. For each point on the xy plane, we have z value. If each point on the xy plane, if we have a z value is nothing but fxy. So any position vector is xi plus yj plus fxyk. If that is true, then how much I can see dp by dx, means variation in p along the independent component x. So zx plane, if I cut down zx plane, in that plane, what is dfxy by dx? I mean dp, not dfxy by dx, dp by dx. If there is a position vector p, that is xi plus yj plus zk or fxyk, that position vector, how much it is changing per unit change along the x-axis. How much it is changing per unit change along y-axis. dp by dx, dp by dy. So one is xi plus yj fxyk. One is I plus dfxy by dxk. One is j plus dfxy by dyk. Now, if I go, now this is the class of the algebra and vector. Now, what we got dp by dx, dp by dx is a vector. That is rate of change of p, means how p would change along the x-axis. If there is 1 unit change in along x-axis, how much p would change. If there is 1 unit change along y-axis, then how much p would change along the independent component y. Okay, but dp by dx itself, that is I plus dfxy by dxk, and dp by dy, that is j plus dfx by dyk. These two itself are vectors, algebraic vectors or parameterized vectors, where each component of the vector is again function over x and y. These are called parametric vector. Vector with parameter x and y, also called vector field or velocity vector. This is not typical parametric vector people talk, where independent component is one, that is t. But still, it is a kind of a vector function. So vector, algebraic vector, better we can say algebraic vector. So algebra is nothing but function over independent component. Then this is a algebraic vector. One is I plus f dfxy by dxk, and one is j plus dfxy by dyk. Now this is one vector along x-axis, means the rate of change in p along x-axis. There is another vector rate of change of p along y-axis. If I do now, if there is something along x-axis, if I have another vector along y-axis. This is velocity vector. dp by dx is velocity vector. dp by dy is velocity vector. Now, if these two vectors, if I take cross product, if I multiply these two vectors, means width by length, then I get the area. But we cannot do the multiplication. You will say area would be, if I talk about surface area of a sphere, then everywhere the area would be something that is curve. Okay, that curve will be taken care by the algebra inside the vector. That is the calculus. Algebra is variable. Okay, so vector would keep changing as per the xy value. In dp by dy also, vector would keep changing as per the xy value. That I don't have to worry, because I have made full worry in getting the algebraic equation. That would keep changing. Now you can go on top layer one. So if I have dp by dx, dp by dy, if I do cross product of it, means product of it. So cross product would work because I want the area. Then dp by dx, if this is the velocity vector, dp by dy, if this is the velocity vector, if I calculate the cross product, it will give in between area, and the direction of the area would be perpendicular to it. This is the cross product. I want area. Okay, so dp by dx, if I remember in 2D where I had a single line, then dp by dx was a velocity vector. Now dp by dx and dp by dy. Now there, if it was a velocity vector dp by dx in single line, then if I calculate the magnitude, that becomes the length. Here if I calculate the magnitude, then it is not a vector. If I calculate the magnitude, then it is not a vector. I want vector. So velocity vector dp by dx, velocity vector dp by dy. If I do cross product, then I get the area. Then I will calculate the magnitude, that is the net area. So if I do the cross product, I get the area again as algebraic equation. So that comes, I remember, minus jfx minus ify plus k. Okay. Now area vector, area is again a vector over algebra. Okay, minus jfx minus I fy, fx means d, fx means dfx by dx. So minus jfx minus jfx minus ify plus k vector. Now this area vector, now I want area, so magnitude. So that will become fx square plus fy square plus 1 square. Okay. Now this is the area of the vector. Now this is the net area I have calculated for the full surface because it is in function of fxy, and fxy keep changing as per the xy. Amazing, right? Now I have to, if I have, so this is d, I mean this is dA by dx dy. I had dp by dx, dp by dy. If I do cross product, then it will be dA by, it will be kind of velocity vector by dA. Velocity vector by something like velocity vector by dA, dx and dy. If I do multiplication of d fx by dx, sorry, dp by dx, dp by dy, if I do cross product, then if top, if I consider as velocity vector, then it will be d2v by dx dy, because multiplication d2v, but velocity vector d2v or d2v or something like that, or by dx dy. Now if I calculate the kind of area, then it will become dA by dx dy. Now the dp into dp, top numerator, if I multiply, it becomes area. This is what we have seen. One is in x-axis, what is y-axis velocity vector. If these two velocity vectors, if we multiply, it gives the area in between. Now dA by dx dy. If I integrate over x dx and dy, I get the area. Simple, right? Now, what is dA? That is fx square plus fy square plus 1 square root. Now what is fx? dp, fx is nothing but what is the function. Now see what is the equation of a sphere. That is x square plus y. That is fxy equal to, or if fxy is z, then x square plus y square plus z square equal to radius square. That is the equation of a sphere. X square plus y square plus z square equal to r square. Let's consider radius as 1. Let's consider radius as 1. Then z equal to 1 minus x square minus y square root, means fxy equal to 1 minus x square minus y square root. That if this is fxy, then what is fx? dfx by dx, that would come as minus x divided by square root of 1 minus x square minus y square. What is fy? Minus y divided by square root of 1 minus x square minus y square. You have to do differentiation through chain rule. Okay, so this is fx. So fx square is x square, a square root of 1 minus x square minus y square, plus y square, a square root of 1 minus x square minus y square, plus 1 square, that is k vector. So 1 square. Okay, now that would come as x square plus y square plus 1 minus x square minus y square divided by a square root. If I, now I have to take a square, fx square plus fy square plus 1 square whole square root. That will come as x square plus y square plus 1 divided by 1 minus x plus 1 minus x square minus y square. I would repeat it. X square by required, x square by 1 minus x square minus y square plus y square by 1 minus x square y square plus 1 square full square root. So if I take this as numerator, then x square plus y square plus 1 minus x square minus y square divided by 1 minus x square minus y square root, that would come as 1 minus 1 by 1 minus x square minus y square root. Same as what we got in circle, right? In circle it is 1 by square root of 1 minus x square. Here it comes as 1 by square root of 1 minus x square minus y square. There are millions of ways through which you can calculate this. Now this is the net meat. This is the algebraic function we have deduced for the dA by dx dy. The dA by dx dy is 1 by square root of 1 minus x square minus y square. Now I have to integrate with dx and dy. Means I have to integrate this to get the actual area of the circle. Now same thing we will do. If I consider x equal to cos theta, r cos theta, r is 1, x equal to cos theta, then y will become sin theta. If that is the case, now I have to prove x square plus y square plus z square equal to x equal to cos theta, y equal to sin theta, then x square plus y square plus z square should be 1. Now it cannot be 1 because I have to set z also. So I'll introduce another thing as phi. So if I say x is equal to sin phi cos theta, y equal to sin phi sin theta, and z equal to cos phi, then it works. Then x square means sin square phi cos square theta plus sin square phi sin square theta. They will sum up to sin square theta plus cos square theta equal to 1. Now x equal to sin theta, sin phi, this solution is not available anywhere. This is our solution, research solution. You can check anywhere. Okay, pure challenge. It is not available anywhere else. Whatever is available, we'll talk in later session. So now it is sin square. Now it is 1 by square root of 1 minus x square minus y square. 1 by x square is sin square phi cos square theta minus sin square phi sin square theta. Because x is sin phi cos theta and y is sin phi sin theta. It is similar to spherical coordinate. So that would turn as 1 minus sin square phi square root. That will turn as cos phi. So now integration of dx, integration of 1 by sin phi dx and dy. dx integration of cos phi, integration of 1 by cos phi dx and dy. Dx equal to sin phi, okay, dx equal to sin phi, remember dx equal to sin phi cos theta, dx equal to sin phi cos theta, x equal to sin phi cos theta. So dx d phi, if I differentiate with phi keeping theta as constant, x equal to sin phi cos theta. So dx equal to cos phi cos theta, x equal to sin phi cos theta, dx equal to cos phi cos theta. Now we have cos phi cos theta d phi dy divided by cos phi. Cos phi cut down. Now I have to integrate cos theta d phi dy integration. So where x is from minus 1 to 1, y is from minus 1 to 1. Now cos theta d phi, if I have to integrate, it will become cos theta phi or phi cos theta. Cos theta is a constant because theta I have taken as constant. Now sin phi cos theta is x, then phi cos theta is sin inverse x. Someone has to prove this. Sin phi cos theta equal to x, then phi cos theta equal to sin inverse x. Someone has to prove this. Homework. Okay. Sin phi cos theta equal to x, then phi cos theta equal to sin inverse x. If that is true, then phi cos theta is the total net integration, that is sin inverse of x. Now we have one integration is out, but it has limit from -1 to 1. So sine inverse x, 1 means pi by 2. Sine inverse of -1, inverse of minus is minus pi by 2. So it will land up in pi. Now I have to integrate pi dy from -1 to 1. Easy, right? So pi dy -1 to 1. So dy integration is y. -1 to 1 means 2. So 2 pi. It is hemisphere we have calculated. So if it is 2 pi -1 to 1, 1 to 1 hemisphere, then full if I want, then 4 pi. So surface area of a sphere with unit radius is 4 pi. If I take r into consideration, then x equal to r sine phi cos theta, y equal to r sine phi sin theta, and z equal to r cos phi. Now if I substitute, then it will become 4 pi square. So we will do this in next session, and we will try all other solutions that are available on net. So those are the solutions that also we will see how it works with more explanation in length and area. Okay. So idea was to complete this as far as area is concerned. Okay. So this whatever that this will file disclosure on this. So this is the way we can compute where x equal to sine phi cos theta, y equal to sine phi sin theta, keeping theta as constant, and then we calculate it is a 4 pi square. So this is the surface area of a sphere. We will do more on it because this attracts people which has differentiation. This attracts people which has integration. It attracts people because it has vector. It attracts people because it has a vector field. It attracts people because it is a vector with algebra that gives a sign of parametric vector that someone can go further, and whatever we have calculated dA by dx by dy, convert it to complete parameterized vector with single independent variable. Then dx dy will go away and it will come as simple dt. Okay, that will be even simple. So it attracts people. Calculating the curvature area or curve length. We will see more on it.